All right, so I figured it's good to start with what is microsegmentation. So it's a little bit corny, but I do think the submarine analogy really sums it up well. So on the left, we've got a submarine with no compartmentalization, one that obviously wouldn't really exist today. On the right, we have as they're typically designed with several watertight compartments. So the whole concept of, not moving my slide, there we go, of what we're looking at is we're kind of operating on that mentality of like assumed breach. At some point, something will go wrong. Somebody will get unauthorized access to your network. When that happens, the submarine on the left that has no compartmentalization, that's going to flood and it's going to sink. If there's some puncture in the perimeter, in that barrier, it's going to be devastating. On the right, the reason these compartments are designed is so that you could have incidents that aren't going to take down the entire submarine. So when we translate that into like the enterprise network space, obviously that submarine on the left is a flat network. Everything's connected, everything can talk. There might be reasons why you want to design a network that way, but keeping it operating that way obviously poses some security risks. So what we're really helping organizations do is build out these compartments. So when there is some sort of breach, things are very contained. So when we now translate that into the enterprise space, really what it boils down to is microsegmentation is trying to stop the spread of unauthorized lateral movements. So summarizing it in really two words, we're trying to control and contain. We're trying to control any communication in and out of a segment. So we're disrupting that east-west traffic that shouldn't be happening. And we're trying to contain a breach. If a workload, if a server is compromised, an attacker shouldn't have complete access to your environment. It should be very limited in what they can communicate with. So when we look at what's really driving microsegmentation, why are organizations doing this? I think it really boils down to two things. The first one is overall security and the attacks that have been happening. So when we look at historically some of the big breaches, this one is kind of a diagram of the target breach. Most folks in the security space are familiar with it. What happened there is what happens to organizations all over the world. Some low value asset is compromised. Attackers hang out there for a while, they do reconnaissance, and they slowly move their way through the network until they get to some critical asset, some crown jewel, where they're able to start extracting data. It's very rare you hear of some breach where you're just able to get directly to some critical database in the environment and start pulling data out. In the target breach, it was a vendor portal that was breached through an HVAC system, got them into the environment. They were able to work their way over to the point of sale systems. So stopping these lateral attacks is the main driver behind segmentation that for organizations looking to protect their brand, stay in compliance, which really drives the second piece. There are a lot of compliance bodies now that are actually mandating this. So anybody in the retail space, PCI has sections that specifically call out segmentation, segmenting your payment card environment. The SWIFT regulations call out segmentation specifically. The Office of the Comptroller has requirements around segmentation. When they do audits, often there'll be findings around that. So it's always, I think this is pretty common when we look at the security space. There's always going to be that good hygiene, best practices of protecting the brand, making sure that your data is secure. But then there's also going to be some of that regulatory drivers behind it, pushing it. When we get into here now for seeing like what does that boil down to like actual use cases for our customers? So like what are they looking to do when we talk to an organization that's looking to get into segmentation? You'll see over on the left, we have application dependency mapping. This is something I'm going to get into in a little bit more detail, but visibility is king with all these programs. You need to be able to understand your environment before you can segment it. So every use case kind of funnels from that of being able to understand how do the servers in your environment communicate to each other, how do applications communicate amongst each other, how do they rely on core data center services. You need to understand all that before you try and segment anything. Then over here on the right, we've got kind of 4 boxes that summarize some of the use cases. There's always going to be some sort of mix. Organizations are going to have specific requirements to them. But one of the more common that we're hearing is just the environmental separation, keeping dev separate from prod, staging separate from QA. Most organizations are doing something around this today. A lot of organizations have flat networks, but they've got some segmentation in place where they don't have completely dev and prod sitting right next to each other with no barrier. Often they're going to have a firewall separating those, separate VLANs. It's very coarse-grained, can be very difficult to maintain, and it's not always the easiest to scale. We're going to see, and we get into more discussion, that there's a big factor what makes this challenge hard is that we've got dynamic environments. So as dev teams are spinning up new environments, making sure they're always putting it on the right VLAN, making sure that things are configured properly can be a challenge. One of our biggest customers, large bank, where this was the main reason they came to us, was this environmental separation where they had a development platform trigger a trade in production. That obviously throws huge red flags with regulators and audits, and got them into some hot water. They needed to make sure that they had a very robust mechanism for doing that. This is often too where a lot of programs start. These things, like everything in the security space, it's not black and white. It's not, I need to separate environments and that's it. That can often be a quick win. Let's go in and make sure we put up these barriers between these environments, and then let's go get some more fine-grained segmentation. And that kind of leads into the second box over here, the isolate and protect the high-value applications. These are going to be kind of like an organization's crown jewels. A lot of businesses we're talking today have some initiative around protecting and separating out the crown jewels of their business. What we do here is we basically come in and we can put a fence around the servers and the workloads that make up that crown jewel and make sure that they can all communicate to each other as they should, but they're isolated from the rest of the environment. Now, that sounds like something that could be fairly easily done today, but again, that dynamic nature of data centers where it's no longer just your data center. You have some environments living in one physical data center, some in another, some in a public cloud. Getting that ring fence around that application can be difficult. We can talk a bit more about how we do that. The bottom one on the left here, the secure hybrid environment. These two, and especially the migrate applications to the cloud, these are pretty connected in my mind where, again, it just goes to the dynamic nature of today's data centers where most organizations have some sort of cloud initiative. It makes sense to bring some workloads to AWS. Some environments are saying they want to get rid of their data centers and go 100% cloud. I don't think that is tenable for most organizations where they're going to have some private data center always. It makes more sense to have some workloads running on bare metal servers or virtualized servers in their environment. But as you do that migration, as you bring servers to the cloud, as you have that functioning hybrid environment, how you secure the communication, how you isolate workloads can be very challenging now. Clouds have means of doing it. Amazon has their security groups. Same thing with Azure, they got their network security groups. And you can get some pretty good isolation in their environment. But when these workloads need to then talk back into the data center, there's communication there, trying to have everything in sync with your security groups, your firewall rules, your VLANs, your ACLs, that's where stuff starts to get really complicated. And you end up having to sacrifice the fine-grained segmentation you want for just being able to maintain it and have the functionality you need. So with that in mind, what exactly does Illumio do? We can really boil down what we do to 2 points. The first one is we build a map. So we take an organization's compute environment. It doesn't matter where it is. Physical servers in your data center, virtual servers running on any hypervisor, containerized workloads running on-prem, public, private cloud. We want to visualize all the communication between these workloads. And we're not building a network topology map with every device in the network. It's very application-centric. You want to be able to look at this map and clearly see how do the servers that make up an app talk to each other. Simple example, how does my web tier talk to a processing tier, talks to a database tier, and what does that other application rely on? How does it talk to other things in my data center? So we want to build you that map so you can understand how the data center, how the cloud environment works. And we want to enable you to be able to segment that environment. So you probably have heard zero trust, one of the big buzzwords in the security space now. We're following that model. We want to make sure that only things that should talk to each other do so. What we do is very connected. Even though it's two things of giving you visualization and allowing you to do segmentation, you can't have one without the other. So the map is what allows you to be able to segment, to be able to do that whitelist zero trust model to say, let me observe how my data center works. Let me make sure this is what I want. Now let me use this historic monitoring to make sure that's all that happened. Now, there's obviously a lot of challenges with this. Like, that's a good goal of making sure that only things can talk should. What I think really makes Illumio shine like in this space is the way that we address these different environments. So I've mentioned before dynamic. One of our big customers is Salesforce. They obviously have a very dynamic environment. They're spinning up workloads all the time on demand. We're tied into that system in a very DevOps way. Most organizations are pushing that, where they want to be able to have the workloads coming up on demand with security in it. Distributed, we've already talked about that. We've got every organization is going to have workloads in different data centers, different cloud environments. They need to be able to make sure they can talk to each other. You need to make sure your model is going to work distributed. I think heterogeneous is one of the more important areas that people don't think of right away, but becomes very clear as they start to roll this out. I'm going to talk in a little bit about how different solutions might approach this, but what really it boils down to is there could be ways to do segmentation on all of these, where there's specific container solutions, there's specific hypervisor solutions, but organizations don't have everything virtualized. They don't have everything running on containers. When we start conversations, often it appears that way, where it's, oh yeah, we're 90% virtualized, but that 10% that's running on bare metal, those are often the crown jewels. Those are often the most important servers. Most organizations have that push to DevOps, which includes exploring container technology. Very few are there yet, but as you go there, you need to make sure that those containerized workloads can function with the rest of the data center. So it's something that you need to make sure as you're doing the segmentation that you have something that can function in all these different compute environments. And then, of course, going right with that is the cloud. And we've talked already about that, how it's typically not we're 100% AWS now. Even if that's your goal, it's going to take years to get there. You're going to have a hybrid environment where you've got stuff running on your local data center as well as in that public cloud. So just to kind of hit home that these environments are complex. And I apologize, it looks like some of the graphics might be getting a little warped, but you can still see it. This just shows what a map might look like of just 70 workloads. Now, this is something that Illumio will give you. Of course, this is not the end state of, hey, we visualized your environment. I'll show you a little bit more what that looks like of how we can get this to actually make sense, but just in kind of its raw data form. This is what the communication looks like between 70 servers. 70 servers is a very small environment. Any sort of organization that is in the enterprise space are going to have hundreds, thousands, tens of thousands of servers. So you can imagine how complicated this can get. So we talk about how we might want to segment this. This just kind of shows a little bit of, historically, what have organizations been doing, how they've been trying to tackle that problem. And we kind of put it into 3 different buckets. Obviously, it's not always crystal clear of 3 distinct lines, but this kind of summarizes a little bit of the different approaches. So on the left, we have segment on the network. The traditional approach used to always be, let's do this with hardware. Let's get it with network devices. We have firewalls, we route traffic through them. They'll have our ACLs. We can control what we want there. That works all right in the private data center. It's very difficult to get to a level of granularity that you ultimately would want. And then it really starts to fall apart when you get into the hybrid data center environment with the public clouds. Another approach is the segment in the hypervisor. For example, some folks might be familiar with VMware's NSX, where it's a distributed firewall in the hypervisor. Again, that would work for some environments in your virtual space, not the easiest to scale. But then once you get outside the hypervisor, like we're talking about, not everything is virtualized. You're going to have containerized workloads running in VMs. That might not apply to that. You're going to have things running on bare metal. And again, that public cloud support didn't scale out well for those environments. The third approach, and this is where Illumio fits in, we'll talk about how we do this, is segmenting at the workload. So every workload you've got in your data center has a stateful firewall built into it. The challenge historically with using those has been any sort of coordination at scale. That large bank I was talking about that came to us originally for separating their environments, they tried to do essentially what Illumio does, but they were doing it manually, where they were trying to control Linux IP tables for their environments, because they knew that they need to do the segmentation at the host. That was the way to get this to work. Just getting that to do it at scale in a coordinated fashion was the challenge. And that's really what Illumio does. And I'll talk a little bit about how we do it in a way that addresses that scale problem. So our big punchline when we're talking to folks is that you don't need to go out and buy more firewalls and buy more hardware to get the segmentation you want. You have these enforcement points already in your data center. Primarily what we're talking about here are Linux IP tables, Windows filtering platform. Those are the layer 3, layer 4 stateful firewalls that exist in every operating system. That's Windows and Linux. We also support AIX and Solaris that are using IP filters. On top of that, there's going to be devices and compute in your environment that don't fall into those operating systems, mainframes, IP cameras. That's why we're using things like Cisco and Arista switches to program ACLs, F5 load balancers to program iRules. Eventually, we're also programming security groups out in the cloud for platform as a service and things like that, where they don't fit neatly into those operating systems. but the theme is still the same. It's not a matter of going and buying and deploying more enforcement points, which adds complexity to your environment. It's a matter of giving you a way to leverage what you have today. So I'll walk you through a little bit of, this is the Illumio approach. How do we actually do this? So we have your environment. Again, it doesn't matter if it's on-prem data center, if it's public cloud, you have your compute. Whoops, wrong way, 1 second here. The first piece of software we have is called the virtual enforcement node, or the VEN. This is a lightweight agent you would deploy to all of your workloads. Now, every time we say agent, people are immediately going to roll their eyes and think to themselves, no, not another agent. We don't want that. So I think it's important to note kind of what is our agent doing. This is not an agent that's going to be getting it's not going to be getting in line with traffic. It is just basically a sensor. We call it more of like an antenna where it's sending information about the workload and it's receiving instructions on what to do. It is not routing traffic through it. It's not a kernel modification. It's a very, very lightweight piece of software. And I think one of the things that speaks best to how this operates is, again, some of the production environments that we're in, where we're working with about 10 of the largest 15 banks in their production systems, closing in on 100,000 workloads. They've obviously put us through the ringer of making sure that there's very little performance impact. But we want to be as close to the operating system as we can be to get the information we need. So essentially what this agent will do is it sends data to the policy compute engine. That's the second piece of software called the PCE. It's essentially the management console. It's the brains of the operation. So the VEN is going to collect information like what operating system am I running? What are my IP addresses? And then what connections am I making? It's not sending the traffic up. It's not looking at the payloads. It's going to be sending the source and destination IP, the port and protocol. That basic information, and it's sending it in a summarized form, so it's a very limited bandwidth. The policy compute engine will take that, and then we're also going to apply labels to your servers. Now, when we were founding the company, they were very diligent, like how did they want to do this labeling schema? And essentially what it boiled down to is these 4 labels of what is the role of a server. Is it a web server? Is it a database server? Is it a processing server? What application is it a part of? What environment does it live in? And where is it located? So environments are things like prod and QA. Location could be AWS East, my New York City data center, my Boston data center. With these labels, the policy compute engine is able to take that messy flow we've seen before and now create a useful application dependency map. With that map now, you'd have an interactive tool to build out your policy. So what you can do now is you can use the labeling for everything to guide your segmentation. If I want to segment my environments, it's a simple rule that says, allow any prod workloads to talk to any other prod workloads. Allow any dev workloads to talk to any other dev workloads. With those 2 rules, I just made it so prod can talk to prod, dev can talk to dev, but any server that's tagged as dev can never talk to prod. If I wanted to do a ring fence example where I want to isolate some workloads, again, I don't care where they're located in AWS or on-prem. Say I want to isolate my CRM application. I could have a rule that says allow CRM workloads in my US prod to talk to other CRM workloads in my US prod. Now, only workloads that share those 3 labels, CRM, web, prod, and US, can talk. We don't necessarily care what their role is because we just want to put a fence around that application. Now, of course, we can get even more granular where we take in that role account, and that's how we can tier out your app. To say only my web tier can talk to my processing tier. Only my processing tier can talk to my database tier. That way, web can never talk to database directly. And you can even start to roll in port protocol servers into that information to get really restrictive. So you build all this out in the PCE, and then the PCE takes what you've written in that natural language using the labels, and it calculates what are the host-based firewall rules that are needed. What IP tables rules, what Windows filtering platform rules, and again, for AX and Solaris, it'd be IP filter rules. It calculates those, and it sends them back down to the VEN. The VEN takes the rules and programs them into the host-based firewall. So even though we call it the virtual enforcement node, again, that agent isn't doing any enforcement. It's not routing the traffic. It's not packet filtering. It's using what's built into the operating system. It's just coordinating programming them. Now, this becomes a very virtuous cycle now where that's why we call our platform the adaptive security platform. If a workload gets a new IP address, it sends that up to the PCE, says, hey, here's my new IP address. PCE recalculates the IP table rules that are all affected for any workload, sends them back out. And again, in that dynamic nature, let's say I'm scaling my web tier. I spin up a new web server. You have Illumio as part of your server build. It knows when it comes up. You have it come up pre-labeled. So it says, hey, I'm a new web server as part of this application in this environment at this location. PCE sends it down to the rules, also sends rules to every other server that needs to communicate to it. Because we're writing inbound and outbound rules in these environments. So it's a very distributed security model. You need to have a rule that allows the outbound connection and the inbound connection. So everything that gets affected would be updated in a matter of seconds. So basically what this does, it takes that mess we were looking at before, and it really builds you up that interactive tool for segmentation. We're now in this view, the only difference between this messy view and this more organized one is the labeling. I've taken my label information, and now I'm grouping my servers by 3 out of those 4 labels. So here on the top left is my ordering application in my production environment in my US data center. Within the bubble, I can see I've got a load balancing tier talking to a web tier, talking to a processing tier, then talks to a database tier. So I can clearly see this is how my application operates. I can see how applications might talk to other apps in the environment. An important note too is you don't need to group including this location label. So if you're in that hybrid environment where you've got workloads in AWS, maybe this web and load balancing tier is in AWS, processing and databases on-prem. You could just say, you know what, I don't want to group by this over here, so I'm just going to show you ordering and production, and then it doesn't matter where it's located, but you get the same view. And then you go through and you're building your policy. We had mentioned before, whitelist model. That's why you see some different colors here. Green means I have written a policy to allow this connection. Red is I have not written a policy yet. And there's going to be times where you don't want this. So for example, here's an example where I've observed traffic between a development instance and a prod instance, but I'm done writing my rules. This is still red because I don't want to allow that. And I'm of course not going in and clicking every single flow to make it red or green. You're using the labeling, and then the labeling goes out and calculates the rules. And once we have this environment, we can start doing some other cool stuff with it. So for example, one of the new things we're doing is taking vulnerability data from Qualys, Rapid7, Nessus, and overlaying that on your map. So now we can take your vulnerability data, overlay it on your servers, and get some information of how are these servers communicating with what types of critical vulnerabilities. It puts a different lens on the vulnerability data you're probably used to seeing, where now it's going to give you the context of what does this actually mean? Like how exposed is this server? I've got a critical vulnerability, but if this server can't really talk to anything, okay, maybe it's a little bit less impactful. Whereas if I see a critical vulnerability on something that's exposed to everything in my environment, that could be way more severe. So we give you an east-west exposure score that takes into account that information. On top of that, everybody who's ever been in vulnerability management knows you can't always patch everything right away. We will suggest policies of how can you segment some of your more vulnerable servers to really lower that east-west exposure score and basically bring in segmentation as a compensating control, where until you can patch it, at least now you know it's more locked down. That's really the overview I had. A quick time check, I think.